Welcome to the Lab Report. I'm your host, Paul Krampitz. Today we're going to be talking about nanotechnology. Nanotechnology is an incredibly fast advancing material science. The uses for nanomaterials are expanding at a mind-boggling pace. In fact, it's probably easier to say where nanomaterials are not used rather than where they are used. For example, did you know that nanomaterials are used in your food, medicine, clothing, cars, cell phone, cosmetics? While these nanomaterials are incredibly helpful for improvement of everyday products, it's still unclear what happens to these nanomaterials once they find their way into the environment. For example, what happens to the nanomaterials found in your clothing after you wash your clothes? Is nanomaterial made with silver any more or less toxic than routine dissolved silver? The answer to these questions, along with studying the manufacturing of nanomaterials, requires the analysis of these nanomaterials, and using one of the most powerful tools for this analysis is ICP-MS. ICP mass spectrometry is capable of detecting discrete nanoparticles down to as small as 10 nanometers, 10,000 times smaller than microscopic bacterial cells. In addition, ICP-MS is capable of determining several characteristics of these nanoparticles, including elemental composition, particle size, particle concentration, particle size distribution, and particle agglomeration, as well as the dissolved elements that may be present in any given sample. Only ICP-MS instrumentation can provide this much information about nanoparticles, and only the PerkinElmer NexION ICP is capable of this advanced analytical technique right out of the box. No extra hardware or software is needed. Sample preparation is easy and leads us to another important aspect of this analytical technique known as single particle ICP-MS, or SP-ICP-MS. In order to see individual nanoparticles, the sample presented to the ICP-MS must be dilute enough such that the discrete nanoparticles traverse the plasma one at a time. Otherwise, concurrent particles will be read as one particle that is much larger than either of the discrete nanoparticles. So, to prepare the samples, all you need to do is dilute them, typically with water, sometimes organic solvents. No acid digestion, microwave digestion, none of this is needed. In order to see the individual nanoparticles one at a time, the instrument must be very sensitive, in other words, have a very sensitive detector, and also one that's incredibly fast. These events do not last very long. Only a detector and an ICP instrument that are designed for SP-ICP-MS can handle this tall order of needed or required sensitivity and speed. Inductively coupled plasma spectrometry does not have the needed sensitivity, and most ICP-MS instruments do not have the advanced detector design or necessary software to crunch the data and provide easily understood results. A typical nanoparticle event within the plasma only lasts about a half a millisecond. And unfortunately, most ICP mass specs have a dwell time per mass that's greater than 1 millisecond, so those events are missed. To make matters worse, most ICP-MS instruments have settling times, or a dead time where the detector is not collecting data, which also leads to a bias in the particle sizing, concentration, and distribution. Again, only the PerkinElmer NexION ICP-MS is capable of meeting all these needs for SP-ICP-MS. SP-ICP-MS has proven to be a very powerful tool for characterizing nanoparticles and is a critical technique for manufacturing processes, R&D for academia and commercialization, and for environmental monitoring as well. Extensive studies and papers have proven that the NexION ICP-MS can provide more nanoparticle characterizations than any other analytical technique and is more capable than any other ICP currently on the market. I hope you found this information useful. Thank you for joining us again for another episode of the Lab Report. I hope you learned something. You'll be smarter tomorrow.